Hello, my name is Samir Honda, and today I'll be discussing the abacus, also known as the world's first computer. The abacus is an ancient counting frame that has been used for mathematical calculations for thousands of years, even before the invention of the Arabic numeral system that we use today, which was developed in the 6th century. The abacus is one of many devices created by merchants who needed a way to keep inventory of the goods they sold. However, the exact origin, including the time and location of its first invention and use, are still unknown. The etymology of the word abacus can help us to better understand its foundations and what it was used for in the past. Abacus is likely derived through its Greek form abakos from a Hebrew word ibek, which means to wipe the dust. Thus, we can conclude that the earliest abacus was probably a board or slab used by the Babylonians so they could trace letters and figures for writing and calculating. This makes sense because certain versions of the abacus in other parts of history share similar structures. A Roman form of the abacus was depicted here was a smooth table with grooves and small balls that could be slid up and down these grooves, similar to how beads are slid up and down rods in many other versions that will be shown later. The abacus has been adopted across several different cultures and countries. Romans, Russians, Chinese, and Japanese societies have all utilized the abacus across thousands of years, modifying it slightly to fit their own needs. There was even a brief period in the 1800s in which uneducated factory workers and children could use the abacuses to do simple calculations. There's such an incredible diversity of abacuses because their widespread use across almost every continent. There are Mexican variations with 13 beads, Roman variations on clay tablets, East Asian variations with an upper and lower deck, and even Mesoamerican versions with the beads on a connected cord. Despite this broad diversity, all abacuses have essentially the same structure. A basic abacus is typically wooden and consists of a square frame with several rods and a few beads that slide along each rod. Some of the variations use the rods horizontally while others use them vertically. For explanation purposes, I'll be discussing abacuses with their rods oriented vertically. In all abacuses, each rod represents a power of 10. For example, the far right rod represents the ones values, while the one to its left represents the tens, and the one to its left represents the hundreds, and so on. However, because these values are assigned by the user, they can also represent decimals. For instance, the far right one would represent the hundredths, while the one to its left would represent the tenths, and the one to its left represents the ones. Regardless of what values the user assigns, operations work similarly across variations. In their resting position, the beads are all slid down, so sliding it up indicates that you're using that value. For instance, in an abacus with the far right column representing the ones value, one bead slid up in the far right column and two slid up in the one to its left would represent 21. The Chinese and Japanese versions, known as the swanpan and the soroban respectively, are the most common abacuses and alter the structure slightly. They use the rods as columns, as explained previously, but divide all the columns with one longer rod to indicate a separation, creating an upper deck and a lower deck. The Chinese used 2 beads on the upper deck and 5 on the lower deck, while the Japanese used 1 and 4 respectively. For the Japanese variation, more commonly used today, the top bead represents a 5 value, while the bottom 4 on the lower deck represent the values 1 through 4, so each bead on the lower deck will represent 1. To perform calculations, the user breaks up each digit of a number into its individual place values and manipulates each rod accordingly. For example, in performing 1234 plus 5678, the user would use each column on the abacus to combine 1 plus 5, 2 plus 6, 3 plus 7, and 4 plus 8. To carry over a digit, when the addition creates a number higher than 10, you simply carry the 1 over to the next column on the left while adjusting the original column to reflect its new digit. For example, in performing 4 plus 8, you get 12. Thus, you will slide up one bead on the lower deck of the column to the left, while sliding up only 2 beads on the lower deck of the original column. This represents the number 12 and helps the user to indicate addition on a place value basis. The abacus is incredibly important for both past and present mathematics. It is considered one of the first computers ever for its ability to perform calculations like addition, subtraction, multiplication, division, square roots, and squaring. It essentially does these calculations by allowing the user to store values. It can thus connect to modern-day electronics computers, which perform similar purposes such as mathematical functions and storing values. In fact, the binary abacus shown here shows how computers manipulate numbers. It demonstrates figures like numbers and letters being stored as a binary system as it would be on a computer. In other words, its original purposes in mathematics have application to computers and programming, which is a modern variation of mathematics. Thank you.